Prepare to be amazed as we delve into the captivating story of the Golden Comet C/2025 K1 Atlas. This celestial visitor has left both amateur stargazers and professional astronomers in awe, and its recent journey is nothing short of extraordinary. The Golden Comet's unpredictable journey. Emerging from the distant Oort cloud, this comet has captivated us with its golden glow and dramatic behavior. It's a story that unfolds in real time, leaving us in awe and curiosity. Discovery and origins, a special find. Astronomers first spotted this comet in May 2025, and they knew right away that it was something special. Its orbit suggested it was a new visitor, possibly making its first trip into our inner solar system. This made scientists approach it with a mix of caution and wonder, knowing that new comets often carry ancient materials and can act unpredictably. Observers from around the world pointed their telescopes at this mysterious object, tracking its every move, brightness, and tail night after night. A close call with the Sun. On October 8, 2025, the comet made an extremely close approach to the Sun, coming within 0.334 astronomical units. This was a dangerous move for a fragile comet, and many expected it to break apart under the intense solar heat. But to everyone's surprise, the comet survived its perihelion, emerging intact. This was a remarkable feat, a true testament to its resilience and a gift for scientists to study. The golden chemistry, a unique glow. After its close encounter with the Sun, observers noticed an unusual color. The comet shone with a warm, golden tint, unlike the typical green or blue glow of most comets. Spectroscopic observations revealed the reason: extremely low amounts of carbon-bearing molecules like C2 and Cn in its coma. These molecules usually give comets their familiar green color, but in C/2025 K1, they are almost non-existent. This lack of gases causes the sunlight to highlight the dust, giving the comet its golden hue. Professional observatories, through platforms like the Astronomer's Telegram and peer-reviewed journals, confirmed this unusual chemical makeup. The data suggests that the comet's nucleus has very little volatile carbon left near the surface, a surprising characteristic for a new comet. Fragmentation, the nucleus breaks apart. In mid-November, the most dramatic development occurred. Telescopes began to reveal multiple condensations at the comet's core. Images from the Virtual Telescope project on November 11 and 12 showed at least two bright centers within the coma. Over the following nights, more frames revealed three distinct fragments, with some observers even reporting a possible fourth, though it's still uncertain. The Virtual Telescope team used a Celestron C14 telescope mounted on a robotic rig to capture repeated 60-second exposures between November 11 and 19. They processed these frames into a time-lapse animation, clearly showing the fragments moving away from each other, a real-time separation. The motion is slow but steady, a measurable drift. Other observatories, like the Asiago Observatory in Italy, confirmed the fragmentation. Using a 1.82-meter telescope, astronomers recorded three pieces by November 11. Their measurements estimate that one pair of fragments is separating at roughly 2,000 kilometers, a sign of internal stress. The comet's nucleus seems unable to withstand the solar heating, causing it to break apart. Capturing the drama, a golden opportunity. Observers and astrophotographers now have a unique chance to witness and document this cosmic drama. The fragmented comet moves slowly, but its pieces shift every night, creating compelling time-lapse sequences. It encourages repeated imaging, and you don't need a professional observatory to capture it. A good amateur setup, like a mid-sized Schmidt-Cassegrain telescope, can resolve the brighter fragments under dark skies. A stable equatorial mount helps with long exposures, and stacking frames improves detail. Shorter exposures preserve sharper fragment cores. To document fragment separation, take images on consecutive nights using reliable ephemeris tools like the SkyLive or local astronomy software. These provide accurate coordinates, brightness estimates, and trajectory predictions. Submitting your position measurements to the Minor Planet Center, MPC, helps refine the orbits of the fragments and contributes to scientific research. Even with binoculars or small telescopes from dark locations, you might catch at least the brightest fragment or the elongated coma. Photographers can try wide-field images and close-up high-magnification shots to capture both motion and fracturing. A cosmic story continues. No one knows what the future holds for C/2025 K1. Its behavior depends on its internal structure. It may continue to fragment, with some pieces fading as their volatile reserves deplete, while others might experience renewed outbursts if fresh ice is exposed. Its coma could become more asymmetric, and it might develop extended dust or gas tails from separate fragments. Researchers plan to monitor the fragments nightly, tracking their orbits, speeds, and light curves. They aim to obtain spectra of each fragment, which could reveal chemical differences and refine our models of cometary structure. Amateur observers play a crucial role in this effort, as every reported position helps map fragment paths and refine orbits. Reporting to the Minor Planets Center remains essential, with photos, astrometry, and brightness estimates supporting the global scientific endeavor. As the comet evolves, we might witness behaviors rarely seen in new comets. We could catch fresh outbursts or detect fade-outs, each event teaching us more about comet nuclei, the forces that shape them, and their reactions to intense solar radiation. Clear skies and happy observing.